Okay, today's lesson 9-11 is simplifying square roots. We've gone over this before in this course, and you did it in the fall in your Algebra 1 course, but we always like to kind of re-review when we might need this. So you will need to be simplifying square roots in the lesson for tomorrow, which is on quadratic formula. Not every problem will you have to, but you'll run across some that you do need to. So the square roots of non-perfect squares can be simplified using the factors. So example, the square root of 72 is the square root of 36 times the square root of 2. The square root of 36 can be broken apart, 36 times 2. The square root of 36 is 6. The square root of 2 does not simplify, so we have 6 root 2. So we're going to do these examples together to remind you, and then you'll have some to practice on your own. So if I think of factors of 8, it's up to you. You can come up with any factors, but my head thinks 4 times 2. So we have the square root of 4 times the square root of 2. If you see a perfect square, you can just take the square root. The square root of 4 is 2, and then the square root of 2 does not simplify, so we get 2 root 2. So if you see a perfect square, like here, you can go right down to taking the square root and getting your answer. If you do not see a perfect square, you can continue to do this and simplify it other ways, which we'll see as we go along. So let's see, 63. So I said, what goes into 63? Oh, those both are divisible by 3. So I'm going to do 3 times 21. Now you might see a different set of numbers, and that's okay. So you're going to come up with whatever it is that makes sense to you. If these are not perfect squares, so I'm going to simplify and say 3 does not simplify further, but 21 does. 21 is 3 times 7. So I'm looking for perfect squares, and I can't factor. These are all prime. I'm done. But what I can notice is if I were to take these two and put them together, 3 times 3 is 9. I now have the square root of 9, which is 3. So this simplifies. And I always think square root means a number times itself or a pair of that number. So we have a pair of 3's, which the square root of a pair of 3's is 9. Square root of 9 is 3. And then we have the root 7 is left behind. So if you don't see a perfect square, you're looking for pairs that will make the perfect square. So 3 root 7 is the answer. So now let's look at 20. What multiplies to 20? My head says, 4 times 5. The square root of 4 times the square root of 5. And then I notice the square root of 4 is a perfect square. Square root of 4 is 2. Once you take the square root, it comes out of the radical. So the square root of 4 is a perfect square. It is 2. And then the 5 is prime. It can't be simplified. So I just bring down the 5 and I've got my answer. Now let's look at 18. And you might say, well, 18 is 9 times 2. And then we go up, is 9 or 2 a perfect square? Well, 9 is a perfect square. It is 3. So then I can take my 9, square root of 9, make it 3. And then 2 is prime, so I got root 2, and I'm done. I go to 108. What does 108 simplify to? And I go up. Well, I know it's an even number, so I'm going to divide by 2. 2 goes into 10 5 times. 2 goes to 8 4 times. 54. What is 54 simple to? Well, that's divisible by 2 as well. So I'm going to divide by 2 again, and I get 2 and 27. And again, these are all square roots. Sometimes we'd stop writing them, but they're all there. And then I go 27. Nope, not a perfect square, but 27 is 3 times 9. And then I go, 9 is a perfect square. That's 3. So you keep working. If you see a perfect square anywhere along the way, you can make it a perfect square. Again, if you see pairs like this, you can think square root of 2 times the square root of 2 is the square root of 4, which is a perfect square. So if you see a pair, again, if you see a pair of the same number, you can multiply them together and know that it makes a perfect square. Okay? Once you branch a number, it should be gone. So we should put X's through the branches so we don't branch them again. And then we've got this 3 that never got paired. It never got branched. That's a leftover. So we have to bring down that root 3. So we've got 2 times root 3 times 3, which would make 6 times root 3. Okay. So final answer. Number 6, what multiplies to 52? So I say that's an even number, so 2 and 26. And then I go, okay, what multiplies to 26? That's an even number, 2 and 13. And then I say, oh no, I'm trapped. So this is the same idea. A pair of 2's, root 2 times root 2 is root 4. Right? And root 4 is a perfect square. So that becomes 2. And then I have the root 13 from over there. Again, once they're a perfect square, if you have a pair, you can make a perfect square. It can come down as a number. Once you do this, remember these numbers are now gone because they're there. This number is gone because it got branched further. So let's look at number 7. What multiplies to 80? I see 8 and 10. You might see something different. For 8, my brain says 4 and 2. For 10, my brain says 5 and 2. So then I go, oh, 4 is a perfect square. I can take that one right away. Okay, that's 2. And I cross out the 8 and the 10 because they got branched further. And then I have all this stuff left. In my head, I say, oh, look, there's a pair of 2's. And the pair of 2's come together, right, and make root 4, which is 2. So I made a perfect square by the pairs, and I get 2. So now I have that, and the only thing I didn't use, so this is gone because I've branched it down. This is simplified, but I have this root 5, so I need to just bring that down because it never found any partners. And then I multiply this together. 2 times 2 is 4 times root 5. All right, and that's the answer. So let's look at 700. And I say 7 times 100. 7 is not going to do anything, but 100 is a perfect square. The square root of 100 is 10. So I've got perfect square, perfect square. All right, and so now I have a 10, root 7, can't simplify, done. And then 576 is an even number. If I divide by 2, because I can't think of anything else that goes into 576, again, you might be able to, but if not, if it's an even number, divide by 2. 576 divided by 2 is 288. And then I say I can divide that by 2 again. And that would give me 144. This is gone because I branched it. Right? And I go, oh, 144 is a perfect square. If you didn't know that, you could keep branching, but I know 144 is a perfect square. So the square root of 144 is 12. Okay? And then I go over here and I go, oh, look, I have a pair of 2's. So that's really square root of 2 times square root of 2 is a square root of 4, which is a perfect square. The square root of 4 is 2. So now everything is gone. I just have 2 times 12 or 24. So 576 is a perfect square. If you had a calculator, you might have figured that out. Okay, so that's how we simplify our radicals. Once we have a pair of numbers, we can put them back together and make a perfect square. I always like to think if you have a pair, and I used to say this, if you find a friend, so you find a pair, you get to find a friend that's just like you, get to come out. So the pair of 2's comes out as a 2. But the reason why is 2 times 2 is 4, which is a square root, which is 2. So that's how we simplify our radicals. So make sure you do the practice carefully.